Hello my dear student. So today we are going to discuss about the limitation and the uses of cyclotron, and we'll discuss about how much force is there when you are keeping a conductor in a magnetic field. So let's start. In the previous lecture, what we have studied, we have already studied the construction and the working of a cyclotron. What is a cyclotron? It is a device which is used to accelerate charged particle to a high energy, and its working was how it consists of two D's. I told you, those who have not watched, just go that lecture so that you can watch. It consists of two D's, and the two D's are placed between the two magnets. Both electric field as well as magnetic field are present there. And if you are keeping a charged particle between the gap of the two D's, then the charged particle gets accelerated. So today we are going to discuss about the limitation. What was the then we have derived also the expression for maximum kinetic energy. So what was, how it works? It consists of two D's, D1, this is D2. You are keeping a charged particle between them, then the charged particle accelerates. Because of magnetic field, it moves in a circular path. Because of electric field, its velocity increases continuously. So there are two magnets. This is north pole, this is south pole. So today we will learn about the limitation. So write the limitation of cyclotron. They may be asked for short question, or write the limitation of cyclotron. So what are the limitation of cyclotron? What happens if you are keeping an electron in between the gap? Suppose मैं इलेक्ट्रॉन ले रहा हूँ उन दोनों के गैप जो है the gap between the two D's, I am keeping one electron between them. So what will happen? The electron has, remember, the electron has lighter mass. Its mass is very less. So what will happen? Its velocity will increase because according to Einstein rest mass relation, this is actual mass, this is rest mass, 1 minus v square by c square. So what will happen if its velocity increases? Electron is a light particle, so its velocity increases. अगर velocity बढ़ता है तो what will happen? Its mass will increase. Its mass will increase according to this equation. This is rest mass. This is the mass of one particle in motion, whatever it is that. So this mass will increase if the velocity increases. Velocity बढ़ने से क्या होगा? उसका मास क्या होगा? धीरे धीरे बढ़ता जाएगा. So what will happen when the electron reaches here? When the electron reaches here, अभी इलेक्ट्रॉन कहाँ जाएगा? इधर जाएगा, फिर घूमेगा, घूमने के बाद इधर आ जाएगा. What will happen? Whereas we are applying which AC source, AC voltage. So the terminal should change. At that time, the terminal should change. Let us consider at any instant it was positive, this was negative. I am considering for at any instant. Let us consider this is positive, this is negative. So electron gets attracted towards positive terminal. अच्छे से समझो, electron will get attracted towards positive terminal. So it will move because of magnetic field. It will move in a circular path. अभी ये सर्कल में घूमेगा, फिर जब इधर पहुंचेगा, what happens at that time? The terminal should change. That means it should become positive. This should become negative. Next half cycle, because AC has two cycles. One is positive half cycle, one is negative half cycle. The positive half cycle में मान लो, let us consider this is positive, this is negative. So positive होने से this will attract it towards positive terminal and it will move in a semicircular path inside this D. When it reaches here, what happens? The terminal changes. But if the electron moves with a high velocity, मान लो इलेक्ट्रॉन बहुत तेजी से भाग रहा है, इस वेलोसिटी इज वेरी हाई. सो व्हाट विल हैपन? एट दैट टाइम द टर्मिनल does not change. डॉट्स नॉट चेंज, अभी इसको नेगेटिव होना था, इसको क्या होना था पॉजिटिव, it should become positive, it should become negative when the electron reaches here, then it should attracted here. But what happens in the case of electron? In the case of electron, what happens? The terminal does not change when the electron reaches here. When the electron reaches the gap, the terminal does not change. टर्मिनल जब इलेक्ट्रॉन बीच में पहुंचेगा उसी टाइम में क्या होना था, टर्मिनल को चेंज होना था. बट इन द केस ऑफ इलेक्ट्रॉन इट इज ए लाइट पार्टिकल, इट्स वेलोसिटी इज वेरी हाई. सो उसके वजह से क्या होता है, जब इलेक्ट्रॉन इधर पहुंचता है तो क्या होगा, ये टर्मिनल चेंज नहीं होगा. सो द इलेक्ट्रॉन विल स्टॉप हियर, इधर रुक जाएगा, तो आगे नहीं जाएगा, क्योंकि इट्स फ्रीक्वेंसी, the frequency of this should match with the frequency of the electron. That I told, that is resonance condition. इसको जितना टाइम लग रहा है इधर आने के लिए, उसको टर्मिनल चेंज होने के लिए उतना टाइम चाहिए. The time taken by the electron to reach here should be equals to the time to change the terminal, that is the frequency of AC. So both should match, otherwise it will remain in the gap only. So in the case of electron that happens, that means whenever you are keeping an electron in a cyclotron, it accelerates, but it reaches at the gap. At that time the terminal does not change because of lighter particle, its mass will slowly, what will happen, increase. And whenever the electron, one more factor is that mass may be increased, one, and another factor is that the terminal does not change at that time. So the electron cannot be accelerated in a cyclotron. Though electron has negative charge, इलेक्ट्रॉन का चार्ज भी है, नेगेटिव है, फिर भी उसको एक्सेलरेट नहीं किया जा सकता है साइक्लोट्रॉन में, बिकॉज ऑफ इट्स लाइटर बाय हाई वेलोसिटी, इट्स मूव्स विथ ए हाई वेलोसिटी. और कभी कभी ये भी होता है उसका वेलोसिटी बढ़ जाता है, सॉरी, इफ इट्स वेलोसिटी इंक्रीजेस इट्स मास इज आल्सो इंक्रीजेस. एट दैट टाइम as it is becomes heavier, ये फास्टली चेंजेस, दिस टर्मिनल चेंजेस वेरी फास्टली. इलेक्ट्रॉन अभी धीरे धीरे आएगा, धीरे धीरे आएगा. मान लो इलेक्ट्रॉन का मास बढ़ गया, सपोज द मास ऑफ द इलेक्ट्रॉन इंक्रीजेस. सो व्हेनेवर इट विल मूव इनसाइड द डी, इट विल मूव स्लोली. स्लोली जाने से क्या होगा, ये टर्मिनल चेंज हो जाएगा, इट चेंजेस फास्टली. सो इट कैन नॉट बी ऑल्सो एक्सेलरेटेड. तो टू एक्सेलरेट an electron or a charged particle in cyclotron, the frequency should be equal. The frequency, suppose this is 50 hertz, this frequency should be also 50 hertz. Then you can accelerate. और if 49 हो गया या 50 हो गया तभी नहीं होगा, because it will change slowly and it will move fastly. That also is not acceptable. This condition is known as synchronization. This is not there in the syllabus. Just I am explaining in details. This condition is known as synchronization in cyclotron. Synchronization मतलब क्या होता है, जब इलेक्ट्रॉन अभी इधर घूम रहा है, अभी ये गैप में जब पहुंचेगा उसी टाइम में टर्मिनल should change. That condition is known as resonance or synchronization. Resonance condition, that is also you can say. So in the case of electron that does not happen. Either the frequency may be slower or the electron may increase fastly depending on that. So write the limitation, the very first point, just write it. Electrons cannot accelerate in cyclotron. Just write one point, that the electrons cannot accelerate in cyclotron. No need to write the explanation. You can read in book also, you can watch in YouTube also why electron cannot accelerate it. Because the frequency does not match or it goes out of synchronization. It is called as also out of synchronization. इसका फ्रीक्वेंसी और दोनों का फ्रीक्वेंसी मैच नहीं होता है इलेक्ट्रॉन के केस में, इसीलिए उसको we can't accelerate. Then next, one more limitation, neutrons also cannot accelerate. Neutrons also cannot accelerate in साइक्लोट्रॉन. न्यूट्रॉन को भी आप साइक्लोट्रॉन में एक्सेलरेट नहीं कर सकते हो क्योंकि उसको कुछ भी चार्ज नहीं है. देयर इज नो चार्ज इन ए न्यूट्रॉन. न्यूट्रॉन में कुछ भी चार्ज नहीं होता है, इसलिए वी कांट आल्सो एक्सेलरेट न्यूट्रॉन. जस्ट टू लिमिटेशन, नो नीड टू राइट और नो नीड टू गो थ्रू डीपली. नेक्स्ट वन इज यूजेस. यूजेस क्या क्या, व्हाट आर द यूजेस ऑफ साइक्लोट्रॉन? यूजेस भी एक मार्क में शॉर्ट क्वेश्चन में भी पूछ सकता है. जस्ट राइट द यूजेस. द वेरी फर्स्ट इज राइट, इट इज यूज्ड टू प्रोड्यूस हाई एनर्जी पार्टिकल्स. It is used to produce high energy particles to study. It is used to produce high energy particles to study the structure of nucleus. न्यूक्लियस की जो स्ट्रक्चर है उसको अच्छे से पढ़ने के लिए we use cyclotrons so that the nucleus breaks down, so that you can study more about cyclotron. So एक पार्टिकल चाहिए न्यूक्लियस को क्या करने के लिए, तोड़ने के लिए. That high energy is produced by cyclotron, because to break a nucleus you need tremendous amount of energy. ऐसे आसान नहीं है न्यूक्लियस को तोड़ना. You require high energy. That high energy is produced by cyclotron. Then one more use is there. It is used to modify the structure of atoms. It is used to modify the structure of atoms. एटम के जो स्ट्रक्चर है उसको भी आप मॉडिफाई कर सकते हो. यू कैन मॉडिफाई आल्सो बाय यूजिंग साइक्लोट्रॉन, बिकॉज इट प्रोड्यूसेस हाई एनर्जी, सो दैट यू कैन रिमूव वन इलेक्ट्रॉन फ्रॉम अदर साइड wherever you can also modify the structure. Then one more use is there also. It is used to one more uses. It is used to produce radioactive elements. Radioactive elements you have studied in the chapter nuclear physics. Radioactive elements which gives radioactive waves or alpha ray, beta ray, the atoms which or the elements which radiates alpha ray, beta ray, gamma ray. That kind of elements are produced by also cyclotron, because you will modify the structure. Also radioactive elements can be produced, and that are used also. It is used to produce radioactive elements which are used in medical science. जिसको हम लोग कहाँ पर यूज करते हैं? मेडिकल साइंस में we are using that one to treat cancer also. You have seen that chemotherapy, that is a treatment used for cancer patient. So to treat that cancer we need a radioactive element. That element can be produced by modifying the structure of an atom, and that structure is modified by cyclotron by producing high energy particles. Next we are going to study one more thing, that is the force, right everyone? Force on a conductor, current carrying conductor in magnetic force, the magnetic field. Force, this is very important. Force on a current carrying conductor, force on a current carrying conductor placed in an uniform magnetic field. मैग्नेटिक फील्ड। कितना फोर्स लगता है, एक कंडक्टर है, यू आर कीपिंग दैट कंडक्टर इन अन यूनिफॉर्म मैग्नेटिक फील्ड। सो मैग्नेटिक फील्ड के अंदर आप एक कंडक्टर को रख रहे हो। सो आई एम जस्ट ड्राइंग द फिगर। सपोज द मैग्नेटिक फील्ड इज अलोंग दिस डायरेक्शन, इस डायरेक्शन में मैग्नेटिक फील्ड है एंड यू आर कीपिंग ए कंडक्टर। सपोज आई एम कीपिंग ए कंडक्टर लाइक दिस। Suppose the conductor is like this. This is a conductor. It is placed in the magnetic field, which is in this direction. So this is the direction of B, and this is a conductor. You are keeping conductor कैसे अंदर के तरफ. The conductor is inward. The conductor is inward and the magnetic field is in this direction. Magnetic field is towards this side and the conductor is inward to the plane of paper. I am drawing the figure like this. Conductor कैसे अंदर की तरफ. Conductor is like this. It is inward to the plane of paper. I am showing like this so that you can see it is inward to the plane of conductor and plane of paper, and the magnetic field is towards this side. So where will be the force? Suppose the current is flowing in this direction. I am just drawing this point. Suppose at this point the current is along this direction. Current is flowing in this direction. You are connecting with a potential. You are connecting it with a potential so that the current is flowing in this direction. And at this point the direction of magnetic field is towards this side. So in which direction the force will be there in that conductor? You can find the direction using Fleming's left hand rule. So magnetic field is along this direction and the current is outward. Magnetic field is in this direction and the current is outward. Conductor is how the conductor is like this, inward to the plane of paper, and the current is flowing outward. Current बाहर की तरफ आ रहा है, magnetic field इधर है, then where will be the force? Just draw, use your finger, you can see the direction of current is outward, the magnetic field is towards this side, so the force will be towards offside. This is Fleming's left hand rule, we already studied. So remember, at every point you need to understand the Fleming's left hand rule. That is, this is the direction of magnetic field, this is the direction of current, this indicates the direction of force. So magnetic field is in this direction and the current is outward. कंडक्टर से दिख रहा है तो कंडक्टर बाहर की तरफ करंट जा रहा है and force will be towards offside. So at this point the force will be in this direction. So just draw it so that you can understand. You are applying potential. Suppose you are connecting these two. You are applying potential. I am just drawing. You are applying potential. This is, suppose current is towards, suppose this is negative side, this is positive sides of the, you can say you are applying potential to this conductor. Suppose potential of B, let us consider you are applying potential B, so the current is flowing like this, positive terminal से ऐसे आ रहा है conductor. So you are keeping that conductor in an uniform magnetic field. So the force is in upward direction. So you need, in this we need to find the magnitude of this force. What is the expression of the force? You can draw this voltage, or if you are confused, no need to draw this voltage also. Just I have drawn this to understand you that the current is flowing along this direction, that is outward to the plane of paper. So you need to find the magnitude of force. You know the direction, I told you. This is the direction of magnetic field, this is the direction of current, this is the direction of force. तो force ऊपर के तरफ लग जाए तो कंडक्टर ऊपर जाएगा. The conductor will move in upward direction. So how much that force? So you need to calculate that force. That force is how much? You know that force equals to, magnetic force equals to Q V cross B. This is the force on a charged particle. Current is nothing but the flow of charge. Everyone knows that current is nothing but the flow of charge. You can say that if an positron is moving along this direction, the current will be in the same direction. If an electron is moving in this direction, then in this direction the current will be in this direction. So you can say also positive charges are moving along this direction or the negative charges are moving in the opposite direction. That is also same thing. Whatever you are saying, you can say. So it's better to say that this is a positive charge. Let us consider this is a positive charge. So positive charge is flowing in this direction. So current is along the direction of positive charge. So it is better to understand. If you are taking negative charge, so negative charge should move in this direction, force will be in the opposite direction. So don't confuse with that negative charge. So better to take as a positive charge. So current is along this direction, that means the positive charges are moving in this direction. So that Q, you need to find the value of this Q. So how much Q is flowing in this conductor? How much Q is flowing in this conductor? That you need to find this Q. So that the force will be Q into V cross B. This V is that drift velocity. You know that this V is drift velocity or velocity. In the case of a single charge, we called it as velocity, but when a number of charge particles are moving in a conductor, that velocity or that average velocity is known as drift velocity. We have already studied in the starting of current electricity that the average velocity of the electrons or charge particle in a conductor is known to be drift velocity. So you are taking a number of charge particles in a conductor. As you are taking a number of charge particles, you should take drift velocity, not V. V is only for a single charge particle. So try to understand each and every point, whatever I am telling, that are very important. So listen it carefully and also write accordingly, so that you may not confused. So force equals to Q into Vt cross B. Why I have taken it Vt? That Vt is drift velocity. If I am taking a single charge, you can say this is V. So I am taking a bunch of charges that are moving in a conductor, because in a conductor there is not a single charge. There are millions or thousands of charge particles. So this charge you need to find. That to find Q, we need to first calculate let small n be the number of charge particles per unit volume. कितना चार्ज है we don't know, so let us consider small n be the number of charge particles per unit volume. एक वॉल्यूम में कितना चार्ज है, n number of charge particles are there. So what is the total charge? So total charge will be how much? Total charge equals to how much? Total charge equals to how much? That you know n into that you know that Q equals to n into E. So Q equals to n into E. So total charge will be per unit volume. Per unit volume, how much number of electrons are there? N. So total volume n into total volume. Total volume कितना होगा? A into L. This is NaL. That similar to drift velocity. Just remember we have derived in the similar way. Let us consider per unit. इसमें एक जो पर यूनिट वॉल्यूम में कितना इलेक्ट्रॉन है, n नंबर ऑफ चार्जेस आर देयर. पर यूनिट वॉल्यूम में n नंबर ऑफ चार्जेस है. टोटल वॉल्यूम कितना है कंडक्टर का? टोटल वॉल्यूम, सपोज एरिया A is the area of cross section of the conductor, L is the length of the conductor, L is the length of the conductor. So that's why I told you don't draw this one, so that you will not be confused. So simply just draw the diagram that the current is flowing in this direction, and let us consider this length of this conductor is L. Suppose the length of this conductor is suppose L. Length of the conductor is L, and A is the area of cross section. So total volume पर यूनिट वॉल्यूम में कितना इलेक्ट्रॉन है व चार्ज है, पूरे वॉल्यूम में कितना इलेक्ट्रॉन है, दैट इज द टोटल नंबर ऑफ चार्ज पार्टिकल्स इनटू आई एम टेकिंग पॉजिटिव चार्ज, सो इनटू चार्ज ऑफ वन पॉजिटिव इज सपोज पॉजिट्रॉन इज E. You can say it is also minus C, but that is little bit confusing, so just take it as positive or positron. So this is the total charge. Total charge equals to N, capital N into E. Quantization of charge you have studied. N into E. N is the total number of charge particles. So how we will calculate total number of charge particles? पर यूनिट वॉल्यूम में n नंबर ऑफ चार्ज पार्टिकल्स है, टोटल वॉल्यूम में कितने चार्ज पार्टिकल्स है, और एक चार्ज पार्टिकल का चार्ज कितना है, E है, तो पूरे चार्ज पार्टिकल का इतना चार्ज हो जाएगा. सो this is the total charge, that is N, I am just writing NeAl. So this is the total charge, that is Q. इस कंडक्टर में चार्ज कितना है, NeAl. This is similar way we have derived this also in rate velocity. So those who are updated, they also know it. Before few days you have examination, so you have studied that one also. This is the number, I am telling once again, this is the number of charge particles per unit volume, this is the total volume, so this is the total number of charge particles, and charge of each particle is E, so this will be the total charge. After getting charge, just put the values here. So force will be how much? So force will be here, F equals to how much, NeAl into Vd cross B. So this is the force. Just take Vd to this side, L to this side. So how much, what will be here, because we need to relate with current I. So it will be NeAVd, it will be L cross B. This length is along the direction of current. Remember, this length is along the direction of current. So I am erasing, just write it. So force will be how much, finally force will be how much, you know this was, this is what, I equals to NeAVd. You have studied that I equals to NeAVd. You have studied. So you can write instead of this as I. So this will be I L cross B. So this is the expression for force on a conductor in an uniform magnetic field. F equals to I L cross B. So you can also write its magnitude also can be written F equals to I L B sin theta, because you know that A cross B equals to AB sin theta. So you can write also L cross B equals to LB sin theta. This is very important. Those who are preparing for NEET, also JEE, also board exam, especially for competitive examination like who are going to appear medical or engineering. This course they may be asked for one question regarding this formula, that is F equals to I L cross B I L B sin theta. Sometime they will ask the magnitude of this magnetic field also. They will give the mass of this conductor. Suppose the mass of this conductor is 10 kg or 5 kg or 20 gram, then current is flowing in this conductor. Calculate the magnitude of magnetic field. Length with their length also they will give. So how will calculate? that force equals to also you can take equals to at that time force equals to mg. You can just equate so that it is balanced. Suppose the question asked find a magnetic field to balance the conductor of 20 gram or you can say 2 kg or 1 kg. I am just giving an example. Calculate the magnetic field required to balance a conductor of 2 kg of length, suppose 2 centimeter, carrying a current of 2 ampere. So आप ऐसे निकाल सकते हो just according to this formula, and depending upon this theta, that theta is the angle between length and B. Length of the conductor is along the direction of current and B. इसे angle के ऊपर भी depend करता है. मान लो conductor is parallel to the magnetic field. Conductor is along the direction of B. B is along this direction and current is flowing along that direction. Then force is how much? 0. Because sin theta is how much? 0. Sin theta is 0. That's why force is 0 here. Suppose conductor and length or the current are at 90 degree. Then the force will be maximum, that is F equals to ILB. So you can calculate some questions regarding this. So this may be asked for 2 marks also in theory question, 2 marks or 3 marks question. But very important is this formula related numericals. So how I am just giving a quick review. Force equals to Q into V cross B. V is velocity, we know that one. Here as a number of charged particles is moving in a conductor. So we take V as drift velocity. So Q equals to NEALVD into B. How it come? Total charge. Let N. Remember this N is the number of charge per unit volume. पर यूनिट वॉल्यूम में n नंबर है, टोटल वॉल्यूम AL, तो टोटल वॉल्यूम में इतना चार्ज मिल गया और चार्ज ऑफ वन पार्टिकल इज E. सो दिस इज द टोटल चार्ज इनटू V क्रॉस B. सो जस्ट इंटरचेंज दिस टू. मान लो इसमें भी आप इलेक्ट्रॉन ले रहे हो, तो इलेक्ट्रॉन लेने से क्या होगा? दिस इज विल बी नेगेटिव साइन. This will be negative sign. This VD and L. If you will multiply L into VD, this will give you one more negative sign. I am saying for negative charge. If you are considering it as a negative charge, so this L and VD multiplication will give you a negative sign. Charge of electron will have one negative sign. This negative and this negative will cancel out. So finally, plus or positive you will get in answer in positive sign, because this length and VD will be in opposite direction. Remember, if you are taking an electron इधर देखो, electron and current they are in opposite direction. So if you are taking this as a negative charge, so what will happen? Electron will move in this direction. Current is along this direction means electron is moving in the opposite direction. Electron is moving in the opposite direction. So this is the direction of VD. This is the direction of VD along the direction of electron, and this is the direction of length. It is along the direction of current. Remember, these very simple terms are very important, and the smaller thing whatever I am telling, no one is going to tell you also. So each and every term is also important for you. This L is along. Only L, length it does not mean. This L is meaningless. This if someone is telling only length, that is also meaningless. The length along the direction of current, you should mention that one. Length along the direction of current. So it is along the direction of current. Length will be in this direction and drift velocity will be in opposite direction. So if you multiply, it will have a negative sign. This negative sign, again charge of electron is minus E. So this minus, I am saying here minus, it will get finally plus. In SLR aura they have taken in negative sign. Don't confuse with that also. Some people will have confusion with that, so don't be confusion with that one. I am mentioning in the video clearly. So watch it and listen carefully. So this is for this lecture is this much only. Next we are going to calculate the force between two conductors. दो conductor है, the current is flowing in the same direction or in the opposite direction. We have calculated the magnetic field, but we will calculate force. So thank you for watching.